Hey, Math 30-2, today we're going to look at, so we're going to start sinusoidal functions today. Angles can be measured in degrees, where 360 degrees is one complete rotation. A rotation angle is formed by rotating an initial arm through an angle of theta degrees about a fixed point, the vertex. There's our fixed point. The angle formed between the initial arm and the terminal arm, so here's our terminal arm, is called the rotation angle. A positive angle results from a counterclockwise rotation. The diagram below shows an angle of 235 degrees in standard position. A negative angle results from a counterclockwise rotation. The diagram below shows an angle of negative 247 degrees in standard position. Sketch the rotation angle in standard position and state the quadrant in which the angle terminates. So recall, here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So let's sketch the rotation angles. 290 degrees. So we start at the positive x-axis, and there's 90, 180, 270, 290 would be about there. All right. So that's a 290 degree angle right there. And it finishes in quadrant 4. A negative 135 degree angle starts at the positive x-axis and goes clockwise. A negative 90, negative 135 is about there. And it finishes in quadrant 3. And a positive 750 degree angle starts at the positive x-axis. There's 360, another rotation 720, and then 750 would be about there. So this one finishes in quadrant 1. In previous work with angular measure, we've used degrees as the unit of measurement. In order to simplify some of the calculations in mathematics, mathematicians developed an alternate angular measure called Radian measure. So let's do a little exploration. The circle to the right has center 0 and the radius OP. So this equals R. Measure the length of the radius in centimeters. So if you get out your rulers and measure that, you'd find that's about 3 centimeters. Determine the circumference of the circle. Give the answer as an exact value in terms of pi. So formula for circumference is 2 pi r, or pi d, however you want to look at it. So this circumference is 2 pi times 3. Well, the circumference is 6 pi. All right, so that's 6 pi units. Now once you cut a piece of string or thread equal in length to the radius of the circle, place the string or thread on the circumference of the circle starting at point P. Mark the letter Q on the circumference at the other end of the string or thread. Join OQ, state the length of it. So we've got a piece of string the same length as OP. We measure it along here, and maybe Q is right here. So this is also 3 centimeters. There's point Q. It now wants us to join OQ. All right, so that's also the radius of 3 centimeters from the center to the outside. And state the length of OQ. Yeah, we just did that. That's 3 centimeters. And the length of PQ is also 3 centimeters because we cut that string the same length as OP and put it around the circumference. About how many times will a piece of string or thread equal in the length of the radius fit around the circumference of the circle? So if you keep measuring out this length, you keep going around another one, 4, 5. So it's about 6 times you should get. So a bit more than 6. All right. So if we kept going that distance around with the length of the string, we should get a bit more than 6. So radian measure of an angle. The diagram above, the measure of angle POQ is defined as 1 radian. So in general, the radian measure of an angle is a ratio that compares the length of an arc of a circle to the radius of the circle. So the length of the arc compared to the radius of the same circle. That's the definition of the measure of the angle in radians. Length of the arc forming the angle divided by the length of the radius. All right, that formula is on your formula sheet. In diagram 1, the radian measure of angle AOB is given by the ratio arc AB divided by radius OA. Use this definition to estimate the radian measure of angle AOB. So the length of OA is that distance. If I put that around here, that same length will go to about there, and one more time we'll go to about there. So if I estimate that, I would say it's probably about 2 radians. As indicated above, 1 radian is the measure of the angle formed by rotating the radius of the circle through an arc equal in length to the radius of the circle. So this measure, angle POQ, is called 1 radian. That's 1 radian measure. Estimate the degree measure of angle POQ. Well, if I say that's 90 degrees, then I would guess that POQ would be more than half. So maybe we'll say about 60. 45 degrees being half of 90. All right. Converting between degrees and radians. So since an angle can be measured in degrees or radians, it's important to be able to convert from one measure to the other. Consider a circle with a radius of r units. Complete the following. One complete rotation in degrees. Well, we know the measure of once around a circle is 360 degrees. The arc length for one complete rotation would be considered the circumference. The definition of circumference is 2 pi r. So we'd say the arc length for one complete rotation is 2 pi r. That's the circumference of the circle. Which is the circumference of the circle. The ratio arc length over radius then should give us, well, we're told arc length for one complete ratio, or one complete rotation is 2 pi r, divided by the radius, which is r, gives us 2 pi. So in other words, 360 degrees is the same as 2 pi radians. Half the rotation would be 180 degrees. The arc length for half rotation should be half of 2 pi, which makes it 1 pi. Therefore, the arc length divided by the radius, well, arc length should be pi r, I guess. So it should be pi r divided by r, which gives us pi. Or 180 degrees is the same as pi radians. If 360 is 2 pi, then 180 is 1 pi. So to convert pi radians into degrees, we know that pi radians is the same as 180 degrees. So 1 radian should be 180 degrees divided by pi. So to convert from radians to degrees, we simply multiply by 180 over pi. The other direction, if I want to solve for 1 degree, I divide both sides by 180, so pi divided by 180. So if I want to convert from degrees to radians, I simply multiply by pi divided by 180. All right, so if you can remember that, we're in great shape. Note, in mathematics, the symbol degrees following a number means the unit is an angular measure of degrees. If there is no degree symbol after the number, or if it's abbreviated with the word R, with the abbreviation RAD, then the measure's in radian measure. For example, if you wish to write the sine ratio for a right angle, you must write the sine of 90 degrees. If you write the sine of 90, it is now understood to be 90 radians. All right? So here's how you convert. We know that pi radians is 180 degrees. So to go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. Excellent. Page 362. Example 2, convert from degrees to radians. So just from that chart below, we were told to convert from degrees to radians. We simply multiply by pi over 180. So 270 times pi over 180, and that's 180 degrees, so the degree symbols would cancel out. All right, we'd have no degrees left, we're left in radians. So 270 times pi divided by 180. If you go to your calculator, we would have 270 pi over 180. Now we want to put this in lowest terms as an exact value in terms of pi, so we don't want to actually use the pi value, but we do want to do the 270 divided by 180. All right. So we could use our calculator and say 270 divided by 180. And go math fraction. And they'll tell us it's 3/2. So this is the same as saying 3 pi over 2. Do the same thing with 315 degrees. We multiplied by pi over 180 degrees. And we get 315 pi over 180. And the degree symbols will cancel out. We have to simplify 315 over 180. If you go again to your calculators, you're going to get 7/4. So this becomes 7 pi over 4 as an exact radian measure. Example 3, convert the following from degrees to radians. So I've got 70 degrees. I'm still going to multiply by pi over 180 degrees. But now I want the answer to the nearest tenth. So now I include the pi value. So I go 70 times pi divided by 180. And the nearest tenth, this is 1.2 radians. (205 degrees), do the same thing. We're going to multiply by pi over 180. Use your calculators, and we get 3.6 radians. Example 4. Convert from radians to degrees. So now I want to multiply by 180 degrees over pi. So now you know that our pi's would cancel out, so I've got 180 over 4. If you're not sure how to divide 180 by 4, you could use your calculator, but 1/4 of 180 is 45 degrees. All right. 7 pi over 3. Again, we're going to multiply by 180 degrees over pi. The pi's would cancel out. And 180 and 3 would reduce down to 1 and 60. So 60 times 7 is 420 degrees. All right. Example 5, convert 1.57 radians into degrees. So again, we take 1.57, we multiplied by 180 degrees divided by pi. So now we do that on our calculators. 1.57 times 180, divide that by pi. And you get 89.95. So that's really close to the nearest tenth. Yeah, 89.95 would be 90.0. So that's 90.0 degrees. All right. Try part B, 1.4 radians. We multiply that by 180 over pi. You end up with the nearest tenth, 82.2 degrees. All right. using technology to convert between radians and degrees. Convert 60 degrees to a radian measure to 3 decimal places. So set the calculator mode to radian mode. Clear the screen and enter 60. Press second apps and put a degree on it. And select 1 to press enter. Yep, and you get a radian measure of 1.047 radians. So give it a try on your calculator. Make sure you can do that. Let's see if we can. All right. So clear step 1, mode to radian mode. There we go. Go back to your home screen. We want 60 degrees. So you go second, and above your apps is angle. 60 degrees into radian measure is 1.047. Now if we tried it the other way, if we went 60 times pi divided by 180, we should get the same thing. Okay, so the calculator can do it automatically for you. If you turn the page to page 363, we can convert degrees to radians as an exact value. It's just simply a multiple fraction of pi. All right, so if I take this value that we've got, 1.047197551, and we divide that by pi, we get that fraction, and convert that to a fraction, or that decimal, convert that to a fraction, you get 1/3. Now what is 1/3 as a radian measure? Well, we divided by pi, so you have to multiply that by pi. All right, so over here you come up with 1/3 of pi. Right? Here we divided by pi. So now to get my radian measure as an exact value, I would simply multiply it by pi. So you divide by pi, figure out the fractional value, and now multiply it by pi. So 1/3 times pi, or pi over 3. Converting radians to degrees. Convert 3.14 radians to a degree measure to 3 decimal places. So again, it tells us how to do that. Set the calculator to degree mode, so let's follow along. Go to your mode, set it to degrees. Clear the screen and enter 3.14. Hit your second apps, which is your angle menu, and you want to go down to radians, which is number 3. So 3.14 radians, you press enter. In degrees, that's 179.909. So to 3 decimals, 179.909. Nice. All right. Trig ratios in degree mode and radian mode on a calculator. So most calculators have the ability to calculate the values of sine ratios, cosine ratios, and tangent ratios in degrees and in radians. In the work above, we showed that 60 degrees is the same as pi over 3 radians. By using the appropriate mode, show that sine 60 and sine pi over 3 have the same value. Recall that an angle is assumed to be measured in radians unless the degree symbol is present. So let's prove that they have the same value on our calculators. So right now we are in degree mode. So let's go the sine of 60 degrees. That's 0.8660. Now let's change our mode to radians. And we were told that 60 degrees is the same as pi over 3, so we take the sine of pi divided by 3. And in radian measure, that's going to be the exact same value. All right, so they're both 0.8660. So both these values equal 0.8660. Example 6 then. Use a calculator to determine to 4 decimal places where necessary the values of the following trig ratios. All right. So cosine of 280 degrees. Make sure our calculator is in degree mode. So mode, put it in degree mode. And we want the cosine of 280 degrees. So that's 0.4 decimals, 1736 equals 0.1736. The sine of 7 pi over 6. Well, that doesn't have a degree symbol on it, so that must be radian measure. So let's change our calculator to radian measure. And take the sine of 7 pi over 6. So sine of 7 pi divided by 6. And that will give us a value of negative 0.5. Look at part C, cosine of 10 pi over 3. Again, there is no degree symbol on that angle measure, 10 pi over 3, so that must be in radians. Our calculator is already in radian mode, so we can say the cosine of 10 pi divided by 3. Oop. Cosine of 10 pi divided by 3. And we get, again, negative 0.5. And finally, the sine of 90 degrees. Well, it doesn't say degrees beside it, does it? So that can't be a degree measure. Look at A, it said the cosine of 280 degrees. Most people read D as the sine of 90 degrees because we're used to seeing that. But because there's no degree symbol there, it's understood to be the sine of 90 radians. So our calculator is already in radian measure. Take the sine of 90 radians is 0.8940. Equals 0.8940. All right. That's very different than the sine of 90 degrees. If I wanted to figure out the sine of 90 degrees, let's do that in our calculator. It would have a degree symbol there. So now I change my mode to degrees. And the sine of 90 has a value of 1. So the sine of 90 is 1. 90 degrees is 1. The sine of 90 radians is 0.8940. All right. So make sure you recognize if there is a degree symbol after the angle measure. If there is not, then it's in a radian measure. Page 364. Investigating the graph of y equals sine x in degrees and in radians. So complete the following table of values for the domain x is greater than or equal to 0 degrees but less than or equal to 360 degrees. Give your answers to 2 decimal places where necessary. All right? So when x is 0, the sine of 0. So let's put our calculator in degree mode. Great, it's in degree mode. We want the sine of 0 degrees, and that has a value of 0. So the sine of 0 degrees is 0. What is the sine of 30 degrees? And we get 0.5. Sine of 60 degrees. You get 0.8660, so the 2 decimals, 0.87. And away you go. Complete this table. Now that I've shown you how to do it, then you can pause it and complete it, and then you can come back and look. So here's what that chart should look like when it's completed. Plot the points on the grid below, but don't join them. All right, so let's plot these points on the grid below. When x was 0 degrees, use this color, when x was 0 degrees, the sine of x was also 0. When x was 30 degrees, the value was 0.5. 1, 2, 3, 4, 5. So 0.5 is what? Right about there. At 60 degrees, it was 0.87. Right about there. And at 90 degrees, it was 1. At 120 degrees, it was back to 0.87. And then it was at 0.5. And at 100 degrees, it was back to 0. At 210 degrees, it was at negative 0.5. So that's about here. At 240, it was at negative 0.87. At 270, it's at negative 1. Then negative 0.87, then negative 0.5, and back to 0. All right. So we've got those points. Now it asks us to graph y equals sine x on our calculator in degree mode with the following window format. So let's do that. So go to your y equals screen. If you have anything there, let's clear it. If your plot's highlighted, turn it off by pressing enter. All right, so we want to graph the sine of x. And this is in degree mode. Great. Let's get our window setting. Our window setting says x is supposed to be from negative 360 to positive 540 by a scope. Negative 360 to positive 540 by a scale of 30. And y is supposed to go from negative 1.2 to positive 1.2 by a scale of 0.2. And this will match up exactly to our graph then. So if you hit graph, this should look exactly like what we've got in our notes. Part D in our notes says, on the grid, copy the graph from C to complete the graph of y equals sine x between negative 360 and positive 540. All right. So we've got part of this already. We've got this part of the curve. If I join that up. So we've got that part of the curve. They want us to continue this. So there's some key points happening here. We know that at negative 90 it should go to negative 1 and then back to 0. 270 is back to positive 1, back to 0. So I can continue this graph so it looks like that. To negative 360 and to positive 540. At 450 we should be at 1 and at 540 back to 0. All right. So there's the graph just like we have in on our calculator. The stop sign note says y equals sine x is called a periodic function whose graph continues indefinitely to the left and to the right. The graph shown is only a partial graph of y equals sine x on the restricted domain. That restricted domain is from negative 360 to positive 540. All right. Example 7 then asks you to state the following for the function y equals sine x, where x is defined in the set of real numbers and is expressed in degrees. So if we don't have any restriction, like we do in our graph, if there's no restriction on sine x, it tells us it goes on indefinitely to the left and to the right, then the domain for x is any real number. The range, if I look at what's happening, the highest the range ever gets is positive 1, the lowest ever gets is negative 1. So y is greater than or equal to negative 1, but less than or equal to positive 1. And it can be any real number in that range. The x-intercepts, if I go back up to the graph and highlight the x-intercepts, where is it crossing the x-axis? At 0, 180, 360, 540, back here at negative 180 and negative 360. All right, so how am I going to write all of those x-intercepts down? All right, well, it's going forever this direction in that pattern. We said negative 180 to 0 to positive 180 to positive 360. It's going to keep going in that direction. All right, and what's the y-intercept of this graph? If we have a look, it crosses the y-axis also at 0. All right, so the y-intercept is 0. Example 8. Next page. A student was asked to reproduce the graph on the previous page in Radian mode. write down the graphing calculator window the student should use. Well, luckily we've got it in our notes here. They told us it looks like our X window should go from negative 2 pi to positive 3 pi. Negative 2 pi to positive 3 pi by a scale of, well, the scale is tough to say, but how many ticks are there between 0 and pi? 1, 2, 3, 4, 5, 6. So each tick should be a sixth of pi, or pi divided by 6. And our Y window looks like, again, the exact same one we had. It's going from negative 1.2 to positive 1.2 by a scale of 0.2. All right. So let's graph this in our calculator in radian mode. So go to our calculators, go to the mode button and press radians. And if we don't change the window, if we just hit graph right now, we get one crazy looking graph. But we know the sign of X should be the same for radian measure or degree measure. So let's change our window setting to make it match. It goes from negative 2 pi to positive 3 pi by a scale of pi divided by 6. And our Y window can stay the same. So now when I graph it, now we should get the exact same picture we had when we did it in degree mode. So let's graph this thing the exact same way we did for degree mode. All right, here it's at 0, at pi, 2 pi, and 3 pi it's at 0, at negative pi and negative 2 pi it's at 0, just like we had it at 180, 360, and so on. Halfway, it's at the highest point, halfway between 0 and pi. Halfway between pi and 2 pi is at its lowest point, negative 1. All right, halfway here again, it's a positive 1. So that would be about here. All right, so we can finish off this part of the graph. Same thing happens on this side. This graph should be going down, so it's at negative 1 right there, 0, positive 1, right about there. All right. So there's our graph. Now, state the following for the function y equals sine x, where x is defined for the set of real numbers, but now x is expressed in radians as opposed to degrees. The domain this graph still goes forever left and forever right, so x can still be any real number. It's just a radian measure now. The lowest value for y is still negative 1, the highest value is still positive 1, so y should be greater than or equal to negative 1, but less than or equal to positive 1, and it can be any real number between negative 1 and positive 1. The x-intercepts now, again, they go forever this direction, and they're at negative 2 pi, negative pi, 0, then positive pi, then positive 2 pi, and forever in that direction. And the y-intercept is still 0. All right, great. Give this assignment a try, 1 through 9.